66 million years ago, in the unimaginably cold and silent expanse of the solar system, a mountain of rock and metal was falling. It did not know it was falling, of course. It possessed no will, no malice, no awareness of the blue and white sphere growing steadily larger in its path. It was simply obeying the immutable laws of celestial mechanics, following a trajectory that had been set in motion millions of years earlier by a cascade of gravitational nudges. Perhaps it was a subtle pull from Jupiter, the massive gas giant acting as the solar system's gravitational conductor, that first perturbed this carbonaceous chondrite from its ancient orbit in the main asteroid belt. Perhaps it was the glancing blow of a passing comet, or the slow asymmetrical emission of thermal radiation known as the Yarkovsky effect, gently altering its spin and pushing it ever so slightly off course over countless millennia. Whatever the precise mechanism, this sphere of stone, iron, and iridium, measuring roughly 10 kilometers across, had been sentenced to a collision course with the third planet from the Sun. Its journey through the vacuum was a testament to the profound silence of space, a journey measured in eons, hurtling through the dark at a velocity of roughly 20 kilometers per second. It was a leftover building block of the solar system, a pristine relic from the chaotic era of planetary formation, and it was carrying within its frozen matrix the kinetic equivalent of over 100 million nuclear weapons. Before we continue to witness the final moments of this cosmic journey and the devastating hour that followed, I want to take a brief moment to welcome you. I am Frank, the Archaeologist, your guide through the deep corridors of time and the buried secrets of our planet's past. I have noticed that exactly 71.9% of the people who watch these journeys into antiquity have not subscribed yet. If you find peace and fascination in uncovering the mysteries of the Earth, please consider subscribing to the channel. It truly helps me continue to bring these forgotten worlds back to life for you. Now, let us return to that fateful morning, to the sky above the Cretaceous world. Dim the lights, take a deep breath, and let the modern world fade away. Down below, oblivious to the mountain of death plunging toward it from the cosmos, the Earth was breathing. It was an ordinary spring morning in the late Cretaceous period, though the words spring and morning failed to capture the suffocating humidity and relentless warmth of this greenhouse world. The planet was a paradise of rampant biological excess. There were no ice caps at the poles. Instead, temperate forests of conifers and broadleaf trees stretched to the Arctic and Antarctic circles. The oceans were vastly higher than they are today, spilling over the edges of the continents and creating expansive, shallow inland seas that divided landmasses. The air was rich, thick with carbon dioxide levels perhaps 4 times what we experience in our modern era, driving a global hothouse effect that kept the entire sphere sweltering and lush. North America was bisected by the Western Interior Seaway, a warm, shallow waterway teeming with giant marine reptiles. India was a massive island, drifting northward on a slow collision course with the underbelly of Asia, a journey that would eventually raise the Himalayas, but for now, it was a floating Eden of unique evolutionary experiments. In the region we now call the Yucatan Peninsula, the waters of the Gulf of Mexico were shallow, crystal clear, and warm as a bath. Massive reefs, built not by modern corals but by rudest bivalves, formed complex underwater cities. Ammonites with elaborately coiled shells drifted through the water column, hunting for small prey, while long-necked plesiosaurs glided effortlessly above the white carbonate sands, their flippers moving with the synchronized grace of birds in flight. On the nearby shorelines, the dense, humid jungle was already alive with the sounds of the morning. Massive herds of duck-billed hadrosaurs and armored ankylosaurs moved slowly through the underbrush, their heavy footsteps vibrating through the damp soil as they stripped leaves from the vegetation with mechanical efficiency. Tiny, shrew-like mammals scurried beneath the rotting logs, relying on the shadows to hide them from the sharp, forward-facing eyes of small, feathered theropods. It was a world functioning in perfect ecological balance, an unbroken chain of life and death, refined over 165 million years. The dinosaurs were at the absolute peak of their biological success, unaware that the sky was about to fall. If an observer had been standing on the carbonate shores of the Yucatan that morning, looking up at the sky, they would not have noticed anything amiss until the very last seconds. The asteroid was coming in too steep, too fast. It did not streak across the sky like a leisurely shooting star, offering a long, spectacular light show. It approached from the southeast, plunging toward the Earth at an angle of roughly 60 degrees. Because it was moving at 20 kilometers per second, over 70,000 kilometers per hour, it crossed the distance from the Moon's orbit to the Earth in just a few hours. In the final seconds, a new star appeared in the sky, a point of light that grew with terrifying, impossible speed. It became brighter than the sun, a blinding, searing sphere of incandescence that cast hard, shifting shadows across the jungle floor. The animals might have paused, their instinctual fear of sudden light and movement overriding their morning routines. A tyrannosaur might have lifted its massive head, its binocular vision locking onto the impossible glare. A flock of primitive birds might have taken to the air in a panicked flurry of feathers. But there was no time to run, no time to hide, no time to even register the sound of the approaching doom, because the asteroid was moving far faster than the speed of sound. When the 10-kilometer-wide rock slammed into the upper atmosphere, it did not burn up like a typical meteor. It was simply too massive. Instead, it compressed the air in front of it, forcing the atmospheric gases together so violently that they ignited into a superheated plasma. This bow shock, a hyper-compressed cushion of glowing ionized air, pushed temperatures to tens of thousands of degrees, hotter than the surface of the sun. The sky was literally torn apart, the atmosphere unable to part quickly enough to let the intruder pass. As it punched through the stratosphere and the troposphere, the asteroid pushed a column of compressed atmosphere ahead of it, creating a pressure wave of unimaginable force. Before the rock itself even touched the water of the shallow sea, this pressure wave hit the surface, obliterating the calm waters of the Gulf, atomizing the rudest reefs, and pressing the ocean floor down with the weight of a falling sky. The shallow sea was instantly pushed aside, exposing the bedrock of the Earth. And then, the mountain struck. In a fraction of a millisecond, the unimaginable kinetic energy was converted into heat, light, and a seismic shock wave. The collision released an explosion equivalent to 100 million megatons of TNT. The asteroid itself vaporized instantly upon impact, along with thousands of cubic kilometers of the Earth's crust. The tragedy of this moment is not merely in the destruction, but in the profound indifference of the universe to the complexity it erases. Consider the millions of years of evolutionary refinement that existed in that coastal forest. All of this biological tapestry, woven over eons, was undone not by a failure of biology, but by the blind geometry of the cosmos. As the flash of the impact irradiated the landscape, turning the surrounding forests into instant ash before the blast wave even arrived, the reality of the Earth was irreversibly fractured. For a brief, terrible moment, there was no sound, only the silent, blinding flash of a false, deadly sun. The speed of light outpaced the speed of sound, leaving the doomed creatures in a silent, brilliantly lit purgatory. It was a microscopic pause in the timeline of the world, marking the boundary between the age of reptiles and the fire that would cleanse the stage. The history of life is written in these fragile, contingent moments. A fraction of a degree change in a trajectory millions of years ago, and we would not be here. But the trajectory was true, the impact was made, and as the blinding light began to fade, the true mechanical horror of the first hour was about to unleash itself upon the planet. The crust of the earth, normally perceived by its inhabitants as an unyielding and eternal foundation, behaved remarkably like a fluid upon the precise moment of collision. The kinetic energy was of such an immense magnitude that the molecular bonds of the carbonate rock, the shallow ocean water, and the underlying granitic crust were instantaneously shattered. Within the very first fraction of a second, a transient crater was excavated, plunging nearly 30 kilometers deep into the Earth's mantle. To comprehend the staggering scale of this geological excavation, imagine taking the tallest mountain on our modern Earth, stripping it from its base, and flipping it upside down into a chasm 3 times its own height. The sheer walls of this temporary abyss, glowing with incandescent heat, began to collapse inward under their crushing weight. They rebounded in the center to form a peak of superheated rock, taller than any known mountain range, before collapsing again into a churning pool of molten stone. The solid ground simply ceased to exist in this region. Before we follow the vaporized remnants of this destruction as they ascend into the silent vacuum of space, I must pause our journey for a moment. I am Frank, the archaeologist, sitting here with you in the quiet aftermath of ancient catastrophes. It is a humbling fact of our shared digital journey that exactly 71.9% of the people who watch these explorations of deep time have not subscribed yet. If you find comfort or a sense of philosophical peace in these quiet reflections on our planet's violent history, please consider subscribing. It helps tremendously and allows us to continue unearthing the stories written in the bedrock of our world. Let us look up now, away from the chaotic crater and toward the expanding column of fire rising inexorably into the stratosphere. The incomprehensible energy of the impact could not be contained within the shattered crust. It had to find a physical release, and the path of least resistance was upward, back into the cosmic void from whence the asteroid came. A terrifying plume of vaporized rock, superheated steam, and ionized plasma erupted from the center of the crater at speeds exceeding 11 kilometers per second. This velocity easily surpassed the escape velocity of the planet itself. This pillar of primordial fire punched a hole completely through the atmosphere, creating a temporary vacuum tunnel that connected the boiling surface directly to the freezing vacuum of space. Millions of tons of the Earth's crust, intimately mixed with the vaporized remains of the asteroid, were ejected beyond the stratosphere, expelled through the exosphere, and launched into the silent orbital realm. If you could have floated in orbit, suspended safely above the equator on that fateful morning, you would have witnessed a sight of terrifying beauty. The blue and white sphere of the Earth suddenly bloomed with a fiery, rapidly expanding flower of destruction. This cloud of vaporized stone rushed outward in a vast incandescent dome, forming a glowing umbrella that cast a long, dark shadow across the northern hemisphere. Here, in the absolute vacuum of space, there is no sound to accompany the violence. The greatest single explosion in the last 500 million years of Earth's history was a completely silent film. The profound silence of space absorbs all violence, rendering even planetary destruction as a mere distant visual phenomenon. This sharp contrast between the kinetic fury on the surface and the eternal quiet of the orbital void serves as a humbling reminder of our biosphere's fragility. Back on the surface, directly beneath the expanding umbrella of the ejecta plume, the planet was ringing like a massive cracked bell. The sudden transfer of kinetic energy into the deep bedrock generated seismic waves of a magnitude that defies human experience. An earthquake of perhaps magnitude 11 or 12 radiated outward from the Chicxulub impact site. The ground did not merely shake, it rolled and heaved in waves of solid rock, meters high, moving across the continental plates at the speed of sound. 1,000 kilometers away, in the dense forests of the American West, the ground rose and fell so violently that massive conifer trees were whipped back and forth until they shattered. The thick, pillar-like legs of massive sauropods, gentle animals weighing tens of tons, were broken as the earth beneath them liquefied. Whole herds of magnificent dinosaurs were thrown violently to the ground, their balance destroyed by the low-frequency rumble that tore through the crust. Meanwhile, the billions of tons of vaporized rock that had been launched into space began to obey the inescapable pull of the planet's gravity. As this superheated gas met the cold vacuum, it began to rapidly cool, condensing into trillions of tiny spherical droplets of liquid glass. These microscopic remnants of the crust are what modern geologists call tektites. Trillions upon trillions of these tiny glass beads formed in the silent cold of low Earth orbit, creating a vast shimmering cloud that effectively gave the Earth a ring system composed of newly forged deadly glass. For a brief, almost magical moment, perhaps 10 or 15 minutes after the initial impact, this cloud of glass lingered in the highest reaches of the atmosphere, a beautiful halo orbiting a deeply wounded world. It was a momentary pause, a deep breath taken by the cosmos before delivering the next agonizing blow to the biosphere below. But the laws of gravity are relentless and unforgiving. The microscopic tektites inevitably began their descent. As they re-entered the denser layers of the atmosphere, frictional heating took immediate effect. The exact same atmospheric resistance that causes stray meteors to burn up brightly in our night sky now acted upon trillions of individual glass beads simultaneously. The sky across the entire planet, from the immediate impact site to the furthest reaches of the opposite hemisphere, began to glow with a terrifying, unnatural light. It started as a faint red luminescence high in the upper atmosphere, appearing as if a second diffuse dawn was breaking across the entire sky all at once. But this eerie light quickly and brutally intensified. The immense friction heated the falling rain of tektites to sheer incandescence, transforming the entire global sky into a solid, inescapable dome of radiating thermal energy. The atmosphere itself effectively became a massive infrared broiler. The temperature at the surface of the Earth, trapped beneath this falling sky of absolute fire, began to rise precipitously. The thermal radiation delivered by the re-entering ejecta was intense enough to dry out the lush Cretaceous vegetation in seconds, to boil away the morning dew in a single instant, and to spontaneously ignite any exposed organic material. This was the dreaded fire rain. It was not a rain of liquid flame, but a continuous rain of microscopic glowing embers, accompanied by a thermal pulse so severe that it baked the exposed surface of the world. In places where the ancient forest canopy was particularly thick, the broad leaves curled, browned, and blackened before bursting into spontaneous combustion. The comfortable world of the dinosaurs was suddenly subjected to the devastating heat of a global preheated oven. Yet, even within this apocalyptic destruction, there is a strange, terrible poetry to be found. The ancient rock that had rested peacefully beneath the ocean for millions of years had been violently transformed, elevated to the silent heavens, and returned as a falling curtain of starlight. The animals that perished in this blinding thermal pulse did not understand the complex cosmic mechanics of their demise. They only knew that their familiar sky had grown unbearably bright. As we reflect on this first agonizing hour, we are starkly reminded of the fundamental vulnerability of any complex biosphere. Life builds itself upon the comforting illusion of absolute stability, assuming the ground will remain solid and the sky cool. But the universe is governed by physical forces that do not respect these biological illusions. Matter simply changes state. Rock becomes gas, gas becomes glass, and the sky itself falls. As the thermal pulse eventually peaked and the first global wildfires began to spread their thick smoke into the rapidly darkening air, the planet began to cool just slightly, entering a new, darker phase of the catastrophe. Imagine that intense heat slowly dissipating, the terrifying sky dimming to a dull, bruised purple, leaving behind a quiet, smoldering world. The transition from sudden, overwhelming energy to a slow, creeping silence is the ultimate fate of all cataclysms. The raging fire eventually burns itself out, the glass settles quietly into the gray ash, and a desolate peace begins to fall over the smoking ruins. It is a gentle reminder that even the most violent events in the cosmos eventually surrender to stillness, inviting us to rest in the comforting knowledge that we are safely removed, separated by 66 million years from that burning sky. While the sky was raining microscopic fire, and the continents were beginning to smolder beneath the unforgiving infrared broiler, the oceans of the Cretaceous world were responding to the violent violation of their ancient boundaries. The asteroid had not merely struck solid rock, it had plunged through the warm, shallow waters of the Gulf of Mexico, instantly vaporizing countless cubic kilometers of seawater into superheated steam. But the physical displacement of the ocean was far more profound and enduring than that initial blinding flash of vapor. Water is a fundamentally incompressible fluid. It cannot be squeezed into a smaller volume. When a 10-kilometer wide sphere of solid mass is driven into a marine basin at hypervelocity, the resident water has absolutely no choice but to move outward, radiating away from the explosive epicenter in a series of concentric ripples. In the immediate vicinity of the Chicxulub impact site, the initial displacement wave was a towering, chaotic wall of displaced water, churning mud and pulverized marine life reaching perhaps 1,500 meters into the ruined sky. This temporary mountain of water immediately collapsed outward under its own monumental weight, creating a localized deluge that scoured the surrounding seafloor entirely down to the bare bedrock, erasing million-year-old reef systems in a fraction of a second. Before we follow this aquatic leviathan as it races across the globe, I want to take a gentle, necessary pause in our journey. I am Frank, the archaeologist, your companion, shadowed epics of deep prehistory. I have quietly observed that exactly 71.9% of the minds who wander through these ancient landscapes with me have not subscribed yet. If you find a sense of intellectual solace or philosophical comfort in these slow, detailed explorations of our planet's most dramatic mysteries, please consider subscribing to the channel. It supports my work immensely and helps us continue to build this quiet sanctuary of historical contemplation together. Now let us return to the turbulent waters of the late Cretaceous coast, dimming our own lights to match the rapidly encroaching gloom of a wounded, reeling world. As the initial chaotic splash collapsed, it birthed the true megatsunamis. These outward radiating waves were entirely unlike the tsunamis generated by typical tectonic earthquakes in our modern era. Those modern waves are caused by the sudden, localized slipping of fault lines, displacing a modest volume of water. The impact tsunami was generated by the instantaneous excavation of a crater 30 kilometers deep and 100 kilometers wide. The volume of water displaced was beyond astronomical. In the deep ocean basin of the ancient Atlantic, these waves traveled with deceptive stealth. Because a tsunami's speed is dictated by the depth of the water it travels through, these waves raced across the abyssal plains at velocities approaching 800 kilometers per hour, roughly the cruising speed of a modern commercial jetliner. Yet, out in the open ocean, the wave would have been barely noticeable to an observer on the surface. The crest of the wave might have been only a few meters high, its massive energy hidden entirely within the deep, unmoving water column beneath it. It was a silent, invisible assassin moving through the dark depths of the sea. The true, terrifying nature of the mega-tsunami only revealed itself as it approached the shallow margins of the continents. As the leading edge of the wave encountered the rising slope of the continental shelf, the front of the wave rapidly slowed down due to friction with the seabed. However, the massive volume of water trailing behind it was still moving at phenomenal speed. The trailing water crashed into the slowing front, forcing the ocean to pile up upon itself, transforming the fast, subtle, deep water wave into a slow, towering monster of kinetic destruction. Along the coastlines of what would one day become North America, South America, and Europe, the ocean simply stopped behaving like a boundary and became an invading force. Picture the lush, vibrant coastlines of the Western Interior Seaway, that massive inland ocean that divided North America into two distinct land masses. The coastal plains were dense with towering conifer forests and broad expanses of fern prairies, home to massive herds of horned ceratopsians and grazing hadrosaurs. The sky above them was already raining glowing glass, and the forests were beginning to catch fire. The animals that had survived the initial thermal pulse were panicked, disoriented, and choking on the sudden influx of smoke. Then, the ocean began to withdraw. It did not retreat like a normal low tide. The water was literally sucked away from the shore, exposing kilometers of muddy alien seabed, stranding giant ammonites and marine reptiles flapping helplessly in the mud. This eerie, silent retreat was the final warning, the ocean gathering its immense breath before delivering the fatal blow. Minutes later, the horizon vanished behind a wall of black churning water. The wave that struck the coastlines of the Americas was estimated to be between 100 and 300 meters high. It did not break like a normal wave. It arrived as a solid, surging plateau of ocean that marched inland, bringing millions of tons of sand, broken coral, and bodies of deep-sea creatures. As this unimaginable mass of water slammed into the burning forests, it created a chaotic, apocalyptic mixing of the elements. The superheated, burning landscape was violently quenched by the icy depths of the ocean. The collision generated massive clouds of scalding steam that hissed and roared over the roar of the rushing water. The megatsunami ripped ancient trees from the bedrock, snapping trunks 2 meters thick as if they were dry twigs. It picked up massive dinosaurs, creatures weighing 20 or 30 tons, tumbling them in the churning black water alongside boulders and shattered shells. The water surged inland for tens, perhaps hundreds of kilometers in low-lying areas, scouring the land clean and erasing entire ecosystems in a matter of minutes. Yet, even as the water wrought its terrible vengeance upon the land, an even more insidious killer was beginning to gather in the upper atmosphere. The physical destruction of the crust and the oceans was spectacular and immediate, but the chemical legacy of the asteroid would ultimately seal the fate of the dinosaurs. The specific location of the impact, the shallow platform of the Yucatan Peninsula, was perhaps the unluckiest possible target on the entire surface of the Earth. The bedrock there was composed heavily of limestone, but more importantly, it was layered with thick deposits of anhydrite and gypsum, rocks that are extraordinarily rich in sulfur. When the kinetic energy of the impact vaporized these specific rocks, it did not merely throw dust into the air. It performed a planetary-scale chemistry experiment. Within the first hour after the impact, billions of tons of vaporized sulfur were injected directly into the stratosphere, high above the weather systems of the troposphere. In the cold, thin air of the upper atmosphere, this sulfur dioxide gas began to rapidly react with the water vapor that had also been launched by the impact. The result was the formation of a dense global layer of sulfuric acid aerosols. These microscopic droplets of acid are highly reflective, acting like trillions of tiny mirrors suspended in the sky. While the heavy, larger particles of rock and glass from the ejecta plume were falling back to Earth, causing the fire rain, this fine mist of sulfuric acid remained suspended, spreading rapidly around the globe on high-altitude stratospheric winds. As the first hour drew to a close, the survivors on the ground, those who had miraculously escaped the earthquakes, the thermal radiation, and the drowning tsunamis, would have noticed a profound and terrifying change in the quality of the light. The blinding, searing brightness of the fire rain was fading, but it was not being replaced by the familiar golden sunlight of the Cretaceous afternoon. Instead, the sky was taking on a sickly, bruised color. The dense, expanding cloud of sulfur aerosols was beginning to intercept the incoming solar radiation, reflecting the sun's light back into the cold void of space before it could ever reach the surface of the Earth. The shadows deepened. The temperature, which had spiked so violently just an hour before, began to noticeably drop, and a creeping, unnatural twilight began to spread across the globe. This creeping darkness represents the most deeply contemplative phase of the catastrophe. The sudden, explosive violence of the impact was over. The planet had absorbed the blow and burned. But the true extinction, the slow, silent smothering of the biosphere, was just beginning. It is an invitation to reflect on the nature of endurance and the limits of biological resilience. The dinosaurs, masters of their sunlit hothouse world, were utterly unequipped for the cold darkness that was descending upon them. Yet, there is a strange, melancholy peace in observing this transition from a safe, distant vantage point. We can watch the sky dim, knowing that this darkness was ultimately temporary in the vast span of geological time. The fires would eventually burn out, the waters would recede, and the dust would settle. The earth, resilient and indifferent, would slowly begin the process of healing, clearing its skies to welcome a new, radically different world. Let the encroaching twilight of the Cretaceous world serve as a reminder of the quiet that always follows the storm. Allow the fading light of that doomed afternoon to mirror the slowing of your own thoughts, embracing the deep restorative silence that eventually reclaims all things. As the first hour following the impact drew to its devastating close, the immediate mechanical destruction, the thermal radiation that ignited the continents, the seismic waves that shattered the crust, and the towering tsunamis that drowned the coastlines, began to give way to a far more insidious and enduring catastrophe. The sky, which had only moments before been a dome of searing incandescent fire, was now undergoing a radical and terrifying transformation. The billions of tons of vaporized rock, sulfur, and seawater that had been launched into the stratosphere were spreading with unnatural speed, driven by the violent disruption of the global atmospheric circulation. This cloud of debris was destined to circle the entire globe within mere hours of the initial collision. It was not merely a physical barrier of dust, it was a potent chemical cocktail composed heavily of sulfur aerosols and soot from the continent-spanning wildfires that were now raging unchecked across the Americas and beyond. The sun, the primordial source of energy that had fueled the rampant biological excess of the Cretaceous period for tens of millions of years, vanished entirely behind this suffocating shroud. Before we witness the profound silence that accompanied this encroaching darkness, I must pause to welcome you once more to our shared exploration of deep time. I am Frank, the archaeologist, your quiet guide through the buried secrets and forgotten epochs of our planet. It is a curious truth of our digital sanctuary that exactly 71.9% of the fellow travelers who watch these meditative journeys into antiquity have not subscribed yet. If you find solace in these sweeping geological narratives, if you draw comfort from understanding the immense indifferent forces that shape our existence, please consider subscribing to the channel. Your presence helps tremendously, allowing us to continue uncovering these ancient stories together. Now, let us return to the dying light of the Cretaceous world, slowing our breathing as the shadow stretches across the wounded earth. The darkness that descended was not the gentle, comforting dusk of a typical evening. It was absolute, a heavy, suffocating blackness that blotted out the stars and plunged the sweltering greenhouse world into a prolonged and terrifying twilight. This year-long twilight, as scientists now understand it, was the true harbinger of the Great Dying. The sulfuric acid droplets suspended in the upper atmosphere were incredibly efficient at scattering and reflecting incoming solar radiation back into the cold void of space. Because of this impenetrable mirror in the stratosphere, the surface of the planet, which had just been baked by the infrared broiler of the re-entering ejecta, was suddenly deprived of its life-giving warmth. The global temperatures, completely destabilized by the sudden absence of the sun, began a precipitous and catastrophic plunge, dropping by nearly 30 degrees Celsius. This rapid transition from a sweltering tropical paradise to a freezing, sunless purgatory occurred so swiftly that the complex ecosystems of the late Mesozoic had absolutely no time to adapt. The biological collapse was systematic and merciless, unfolding within a geological instant. The plants died first. The towering conifer forests, the broad expanses of fern prairies, and the delicate, newly evolved flowering plants were suddenly thrust into darkness, entirely unable to photosynthesize. Without the energy of the sun to drive their internal chemistry, the foundation of the global food web simply ceased to function. With the vegetation withering and rotting in the freezing darkness, the great herbivorous dinosaurs, the massive horned ceratopsians like the triceratops, and the vast grazing herds of duck-billed hadrosaurs followed next, starving in a world that had suddenly been stripped of its vibrant abundance. And then, inevitably, came the bitter end for the apex predators, the magnificent tyrannosaurs and agile pack-hunting dromaeosaurs that depended entirely on the herbivores for their survival. 3/4 of all species on Earth were gone, erased from the intricate tapestry of life in a cosmic blink, including every single dinosaur larger than a house cat. This is the undeniable objective history written in stone, a tragedy preserved in the thin, dark layer of iridium-rich clay that forever marks the boundary between the Mesozoic and Cenozoic eras. It is the physical manifestation of a 66-million-year-old apocalypse, deeply buried in a 200-kilometer scar beneath the sediments of the Yucatan, serving as a testament to the fact that survival is never truly guaranteed. Yet, as we contemplate this unimaginable scale of destruction, we must also confront the profound, dizzying contingency of the event itself. This catastrophe was not destiny. It was an accident of orbital mechanics, pure and simple. The trajectory of that mountain of rock and metal had been shaped by an almost infinite chain of gravitational interactions spanning billions of years. It was influenced by the distant pull of Jupiter, the slight nudge of passing comets, and the slow asymmetrical wobble of its own spin in the cold silence of space. Some researchers have calculated a haunting alternative reality. If the impactor had arrived just a few minutes earlier or a few minutes later, the rotation of the Earth would have presented a completely different target. It would have struck the deep open waters of the Pacific or Atlantic Ocean rather than the shallow, sulfur-rich coastal waters of the Yucatan platform. Striking deep water would have resulted in significantly less vaporized carbonate rock and exponentially less sulfur injected into the stratosphere. The resulting dust cloud would have been far less dense, the atmospheric blackout far shorter, and the global cooling far less severe. It would have been a devastating regional catastrophe, certainly, but perhaps not a global mass extinction. In that alternative timeline, the dinosaurs would have woken up the next morning to a world deeply shaken, bruised, and scarred by massive tsunamis and localized destruction, but ultimately not destroyed. The long-necked sauropods would have continued to strip the canopy, the feathered theropods would have continued to hunt in the underbrush, and the entire lineage would have continued doing exactly what they had been doing for the previous 165 million years, dominating every terrestrial ecosystem on the face of the planet. This realization, that the existence of the modern world, complete with its diverse mammalian fauna and ultimately human consciousness itself, hinged upon a margin of just a few minutes of planetary rotation, is a thought that should inspire both profound humility and a strange, comforting sense of peace. We are not the inevitable pinnacle of a directed evolutionary process. We are the highly improbable beneficiaries of a cosmic accident. The sheer randomness of the universe does not diminish our existence. Rather, it highlights the delicate, precious nature of the reality we happen to inhabit. As the first hour officially concluded, the Earth was entirely enveloped in the expanding shroud of soot and sulfur, locking in the beginning of a long, cold darkness. The roaring winds of the blast wave were finally beginning to subside, replaced by the eerie, settling silence of a suffocating world. The fires that swept across the continents continued to burn, but their light was muted, struggling against the impenetrable ash that clogged the air. This is the exact moment when the vibrant, cacophonous song of the Cretaceous period was finally and decisively silenced. The giant reptiles that had walked the earth for eons were now ghosts wandering in the dark, their magnificent reign brought to a sudden, inescapable close by a silent rock from the void. But in this darkness, we do not need to find despair or anxiety. Instead, we can find a profound meditative stillness. The cataclysm represents the ultimate reset, the clearing of the planetary slate that allowed entirely new forms of life to eventually emerge from the shadows. The small, shivering mammals that survived in their burrows, protected by the very soil that had been shattered above them, were now the silent, unassuming inheritors of the earth. Let the image of this cooling, quieted world settle into your own mind as you prepare for rest. Imagine the chaotic energy of the impact slowly fading away into nothingness, the roaring, displaced seas returning to their deep basins, the violently shaking continental plates finally finding their solid stillness. The dust is settling, slowly, gently, covering the ruined forests in a soft, monochromatic blanket of gray ash. The intense, frenetic activity of the daylight is surrendering completely to the necessary restorative power of the long night. Just as the ancient Earth absorbed the unimaginable kinetic energy of the asteroid and eventually found its way back to a new, quiet equilibrium, your mind can release the accumulated tensions of the waking world. Allow the vast, incomprehensible geological scales of time to diminish the weight of your immediate worries. The historical contingencies that shape the universe are entirely beyond our fragile human control, and there's a deep liberating peace in simply accepting this fundamental truth. The descending darkness of the prehistoric sky is not something to fear, but a quiet, ancient blanket drawing over a tired world, gently inviting you to close your eyes, breathe deeply, and join the turning planet in its long, silent, and peaceful slumber. As the 60th minute of this apocalyptic timeline approached, the Earth was transitioning from a state of acute, explosive trauma into a prolonged, agonizing shock. The initial flash of the impact, the searing heat of the fire rain, and the crushing weight of the tsunamis had already delivered their devastating blows to the coastal margins and the exposed forests. However, there was another invisible wave that was just completing its terrifying journey around the curvature of the globe. This was the acoustic shock wave, the actual sound of the mountain shattering the crust. Because sound travels much slower than light and significantly slower than the seismic waves rolling through the deep bedrock, the sheer deafening roar of the collision arrived late to the furthest reaches of the planet. In the lush, fern-drenched valleys of ancient Antarctica, which was then a thriving temperate ecosystem, the sky had already inexplicably darkened with high-altitude soot, and the ground had already shuddered violently. The animals there were completely bewildered and terrified by the sudden twilight and the rolling earth. And then, the sound arrived. It was not a thunderclap, but a sustained low-frequency roar of unimaginable volume, a planetary groan that rattled the bones of every living creature. It was the sound of a continent being pulverized, carried through the stratosphere, and rolling across the oceans, a final, terrifying acoustic signature of the world that was ending. Before we delve deeper into the profound, suffocating silence that immediately followed this global roar, I must humbly pause our journey. I am Frank, the archaeologist, your dedicated guide through the dark and silent corridors of deep time. I have noticed, with a quiet sense of curiosity, that exactly 71.9% of the people who watch these nocturnal explorations of our ancient Earth have not subscribed yet. If you find peace in these sweeping historical narratives, and if you draw comfort from understanding the immense indifferent forces that shape our existence, please consider subscribing to the channel. It helps me tremendously, allowing me to continue uncovering these forgotten worlds and sharing their quiet wisdom with you. Now, let us return to the shattered Cretaceous landscape, breathing deeply as the roaring echoes finally begin to fade into the encroaching darkness. The passing of that acoustic wave marked the official end of the first hour, and with it, the absolute cessation of the world as the dinosaurs knew it. What replaced the deafening roar was a silence so profound and heavy that it felt almost physical. But this was not the peaceful silence of a sleeping forest. It was the traumatic silence of an entire biosphere that had been abruptly paused. The normal rhythmic sounds of the Cretaceous afternoon, the territorial calls of massive ceratopsians, the complex vocalizations of feathered raptors, the continuous buzzing of giant insects, were entirely gone. They were replaced by the dull hissing sound of 1 billion burning trees, the distant roar of receding tsunamis, and the relentless, dry whisper of falling ash. The air itself had changed fundamentally. It was no longer the thick, humid, oxygen-rich breath of a greenhouse paradise. It was now a toxic, choking mixture of pulverized limestone, vaporized sulfur, and the acrid scent of burning pine. For the animals that survived the initial blast, this sensory deprivation and atmospheric poisoning were the true horrors of the new reality. To understand the sheer scale of the disruption at the end of this first hour, we must look at the atmosphere, which had been transformed into a chaotic cauldron of extreme weather. The oceans, directly around the impact site and extending for thousands of kilometers, had been superheated by the transfer of kinetic energy. Millions of tons of seawater boiled away into steam, rising to meet the freezing, soot-filled air of the upper atmosphere. This violent collision of extreme heat and sudden unnatural cold birthed massive storm systems with wind speeds that would dwarf any modern hurricane. These storms ripped across the smoldering landscapes, tearing remaining dead trees from the ground and violently mixing the falling ash into a thick, suffocating rain of hot mud. The sky was crying tears of acid and glass, a dark, churning ceiling that offered absolutely no hope of dawn. Yet, beneath this terrifying canopy of destruction, a completely different story of survival was quietly unfolding. While the majestic masters of the daylight were standing exposed and doomed in the falling ash, the true inheritors of the earth were huddled in the absolute dark. The small, shrew-like mammals, the distant ancestors of our own lineage, had spent the last 150 million years living in the terrifying shadow of the dinosaurs. Their entire evolutionary strategy was based on avoiding the attention of the giants. They were nocturnal, scurrying through the leaf litter only when the sun went down. They were small, requiring very little food to sustain their rapid metabolisms. Most importantly, they were burrowers. When the blinding flash of the asteroid illuminated the sky, they were already safely asleep deep underground, or they instinctively dove into their subterranean tunnels at the first sign of the seismic tremors. During that catastrophic first hour, as the surface world burned and drowned, the soil acted as an incredible life-saving insulator. A mere meter beneath the surface, the devastating thermal pulse of the fire rain was barely noticeable. The earth absorbed the heat, protecting the trembling creatures within. They felt the violent shaking of the crust, undoubtedly terrified by the collapse of their tunnels and the low-frequency roaring that penetrated the dirt. But they did not burn. They did not drown in the coastal tsunamis, provided they lived far enough inland. As the suffocating twilight descended, their nocturnal adaptations suddenly transitioned from a niche survival strategy into the ultimate evolutionary advantage. They were already accustomed to navigating in the dark, relying on acute hearing and highly sensitive whiskers rather than eyesight. They were adapted to finding insects and seeds hidden in the soil. The destruction of the sunlit world above them did not end their way of life. Ironically, it completely removed their greatest predators. This contrast presents one of the most comforting philosophical paradoxes in the history of our planet. The dinosaurs were not evolutionary failures. They were the most successful, perfectly adapted terrestrial animals to ever walk the Earth. They dominated every continent and ruled unchallenged for eons. But their perfection was dependent on the specific, stable conditions of the Mesozoic greenhouse world. They were perfectly tuned to a world that suddenly, violently ceased to exist. When the rules changed in a single hour, their massive size and reliance on vast quantities of fresh vegetation became fatal liabilities. The marginalized mammals survived precisely because they were marginalized. Their long exile in the shadows had pre-adapted them for a world of absolute darkness and scarcity. In the grand indifferent casino of evolution, the asteroid was the ultimate reshuffling of the deck, rewarding the hidden and the adaptable over the mighty and specialized. As the first hour bled into the second, and the second into the long, dark days that followed, the Earth fell into a deep, necessary coma. The initial panic of the survivors slowly gave way to the freezing reality of the impact winter. The global temperatures continued their relentless plunge as sulfur aerosols sealed the planet from the sun. The remaining dinosaurs wandered blindly through the ash-choked forests, their calls growing weaker until they succumbed to the dark. It is a deeply melancholic image, but entirely devoid of malice. The universe did not punish the dinosaurs. It simply experienced a mechanical event that altered the atmospheric chemistry. The beauty of this realization is the absolute removal of anthropocentric ego from the history of life. We are not the designated protagonists of the universe. We are all temporary passengers on a fragile sphere, riding out the cosmic storms as best we can. Let this quiet, profound realization settle over you as you continue to relax. Imagine the deep, insulating earth above those tiny, surviving mammals. Feel the safety of the burrow, the comforting darkness protecting you from the raging storms above. The chaotic events of the first hour are over, firmly locked in the unchangeable past. The fire has passed, the waves have receded, and the world is simply resting under a blanket of gray snow. Just as the ancient earth needed that long winter to heal and reset, your mind needs the quiet darkness of sleep to restore itself. There is nothing left to fear from the falling sky, no more shocks to anticipate. The great turning point has occurred, the energy has dissipated, and all that remains is the slow, steady breathing of a world waiting patiently in the dark for a new, distant dawn. Release the tension in your body, just as the earth released the tension of the impact, and allow yourself to drift into that ancient, peaceful, and unbroken silence. But let us deliberately pause this descent into the freezing, suffocating darkness, and intentionally rewind the relentless cosmic clock. Let us consciously pull our perspective back from the ash-choked forests and the traumatized silence, and return our gaze to the cold, unforgiving vacuum of the solar system, where a mountain of rock and metal is hurtling toward a vibrant, sweltering world. In the timeline we have just meticulously witnessed, the trajectory was absolute, a fatal intersection of planetary bodies resulting in an apocalyptic reset that fundamentally altered the trajectory of biological history. But tonight, we are constructing a sanctuary of alternative possibilities. We are going to explore the profound implications of a microscopic deviation, a tiny flutter in the gravitational butterfly effect that governed the asteroid's journey through the deep void. Imagine that millions of years prior to the critical moment, the gravitational pull of a passing comet was infinitesimally stronger, or the slow, asymmetrical thermal radiation emitted from the asteroid's surface caused a fractionally different wobble in its rotation. This microscopic change, practically unmeasurable in its own specific moment, compounded over eons, slightly altering the speed and the precise angle of the rocky Leviathan's approach toward our blue sphere. On that ordinary spring morning, 66 million years ago, the mountain still fell from the sky, carving a brilliant white-hot scar across the upper atmosphere, visibly burning brighter than the sun from thousands of kilometers away. But it did not strike the shallow, sulfur-rich carbonate platform of the Yucatan Peninsula. Instead, it plunged violently into the deep abyssal waters of the Central Pacific Ocean, thousands of kilometers away from the nearest continental coastline. It was certainly not a harmless splash. The unimaginable kinetic energy of the impact still displaced a monumental volume of seawater, generating towering mega-tsunamis that radiated outward in every direction, eventually devastating the low-lying coastal regions of the Americas and Eastern Asia. Millions of individual creatures perished in the churning black waters, and delicate coastal ecosystems were violently disrupted, requiring decades or perhaps centuries to fully recover. But crucially, because the hypervelocity impact occurred in the deep ocean basin rather than a shallow sulfurous shelf, the catastrophic chemical reaction that doomed the dinosaurs never occurred. The vaporized rock and superheated steam ejected into the stratosphere lacked the massive concentrations of sulfur dioxide necessary to form the highly reflective shield of sulfuric acid aerosols. The pulverized dust that was thrown into the upper atmosphere settled back to the surface within a matter of months rather than lingering and blocking the sun for years. The terrifying, prolonged impact winter, the year-long twilight that had frozen the life out of the other timeline, simply never materialized. The sun continued to shine. The lush, humid forests of the late Cretaceous remained bathed in the golden, life-giving light of the sweltering greenhouse world. And the dinosaurs, the magnificent, uncontested rulers of the terrestrial realm, woke up the next morning to continue their ancient, uninterrupted reign. Picture the dense, fern-drenched undergrowth of what would one day become the Hell Creek Formation in North America, a landscape bustling with vibrant, uninterrupted life. A massive triceratops weighing over 9,000 kilograms pushes its heavily armored head through the thick vegetation, its parrot-like beak snapping off tough fronds with mechanical efficiency. It is entirely unaware that it belongs to a lineage that, in another universe, was erased yesterday. Nearby, a pack of agile feathered dromaeosaurs coordinates a complex ambush, communicating with low guttural clicks and sharp, deliberate movements of their plumed tails, their forward-facing eyes locked intensely onto a small, primitive mammal scurrying nervously beneath a rotting log. They had survived worse regional cataclysms in their deep ancient history, enduring the immense volcanic winters of the Deccan Traps eruptions and the shifting of the continents, and they would survive this oceanic impact with the effortless resilience of a biological dynasty operating at the absolute peak of its evolutionary success. They were not fragile, lumbering relics waiting to be mercifully replaced by superior mammalian successors. They were an evolutionary triumph of staggering proportions, having comprehensively dominated the planet for over 165 million years. Their survival in this alternative timeline was not a destined victory or a conscious cosmic reward. It was simply the mundane continuation of an ongoing biological momentum, sustained only because the singular, highly improbable event capable of stopping them had failed to connect with its fatal target. The universe did not consciously spare them, just as it had not consciously targeted them in the real timeline. It merely operated according to blind mathematical physical laws, allowing the grand cacophonous symphony of the Mesozoic to play on into a deep future that was never truly meant to be. Now, we must ask ourselves the central driving question of our speculative journey. What exactly would these magnificent creatures have done with an additional 66 million years of uninterrupted evolution? To understand the trajectory of this alternative future, we must first look at the profound, slow-moving geological changes that were already beginning to reshape their sweltering world, independent of any falling rocks. The dinosaurs had spent their entire collective existence in a stable, warm greenhouse climate where tropical forests extended nearly to the polar regions, and seasonal temperature variations were remarkably mild. But the Earth is a highly dynamic, inherently restless entity, and the long, slow planetary cooling of the upcoming Cenozoic era was already inevitable, driven not by sudden explosive impacts from space, but by the relentless grinding dance of continental drift. India was continuing its inexorable tectonic march northward, preparing to crash violently into the underbelly of Asia and raise the towering peaks of the Himalayas. This massive geological uplifting process would expose vast amounts of fresh silicate rock to chemical weathering, gradually drawing massive quantities of carbon dioxide out of the atmosphere and slowly lowering global temperatures over millions of years. Simultaneously, the frozen continent of Antarctica was slowly detaching from the southern tips of South America and Australia, moving steadily toward its final isolated position at the southern pole. The gradual opening of these new oceanic gateways would eventually create the immense freezing Antarctic circumpolar current, effectively isolating the continent from warm tropical waters and seeding the first permanent massive ice sheets the planet had seen in hundreds of millions of years. The warm, humid, fundamentally stable world that had birthed and perfectly nurtured the dinosaurs was gradually coming to an end, and they were about to face a slow, grinding environmental transformation that would fiercely test their biological adaptability in ways the sudden, localized violence of the asteroid never could. But the most immediate and profound evolutionary pressure was occurring not in the movement of the massive continents, but in the silent, relentless global spread of a completely new kind of vegetation. The flowering plants, known scientifically as the angiosperms, had been slowly diversifying and gaining vital ecological ground throughout the later stages of the Cretaceous period. In our real history, the devastating fiery reset of the asteroid impact rapidly accelerated their conquest of the planet's terrestrial ecosystems by clearing away the ancient established canopy. In our alternative timeline, without the sudden fiery elimination of the established coniferous and fern-dominated forests, their rise would have been significantly more gradual, a slow, competitive infiltration of every available ecological niche. By 10 million years after the asteroid missed its mark, these flowering plants would have quietly revolutionized the underlying structure and composition of the global forests, offering a completely new array of resources, including sweet, highly nutritious fruits and complex, energy-dense seeds, specifically designed by evolution to playfully bribe animals into dispersing their genetic material across vast distances. Before we dive into the specific, astonishing adaptations the dinosaurs might have developed to exploit these new fruiting forests, we must definitively address a persistent and fundamental misconception regarding the competitive balance between the ruling reptiles and the mammalian lineage. There is a comfortable, almost universally accepted narrative in popular science that erroneously suggests the mammals were inherently superior, warm-blooded, and highly intelligent, merely waiting patiently in the ecological shadows for the lumbering, cold-blooded dinosaurs to stumble toward their inevitable clumsy obsolescence. This anthropocentric narrative implies that the extinction event was a necessary evolutionary correction, finally clearing the stage for the true destined inheritors of the Earth. However, rigorous modern paleontological research reveals a starkly different and profoundly humbling reality. The dinosaurs were not suppressed by the limitations of their own biology. They were the absolute, undisputed masters of the terrestrial domain, precisely because they possessed distinct, unassailable physiological advantages that the mammals simply could not match under those environmental conditions. Consider the spectacular respiratory system of the dinosaurs, a genuine marvel of biological engineering that was flawlessly passed down to their modern avian descendants. Unlike the highly inefficient, bidirectional breathing of mammals, where fresh oxygen-rich air is constantly mixed with stale carbon dioxide-heavy air within the tidal volume of the lungs, dinosaurs utilized a superior system of continuous, unidirectional airflow. They possessed rigid, stationary lungs supplemented by a complex, expansive network of internal air sacs that extended throughout their entire bodies, even hollowing out their major bones to create a pneumatic skeleton. When a dinosaur took a breath, air flowed continuously in one single direction across the vital gas exchange surfaces, allowing them to extract significantly more oxygen per breath than any competing mammalian species. Furthermore, this pneumatic, intricately honeycombed skeletal structure allowed dinosaurs to achieve massive, awe-inspiring body sizes without collapsing under their own physical weight. They could grow significantly faster, breathe far more efficiently, and reproduce vastly more prolifically by laying large clutches of shelled eggs rather than enduring the immense debilitating metabolic burden of carrying developing young internally for months. Therefore, as the alternative timeline progressed steadily into the new geological era, the mammalian lineages remained firmly locked into their tiny, nocturnal, marginalized niches, continuously outcompeted by a diverse array of feathered, highly efficient, structurally superior dinosaurian forms that held an unbreakable absolute monopoly over every significant ecological role on the face of the changing planet. 55 million years ago, approximately 11 million years after the catastrophic asteroid harmlessly breached the deep abyssal plains of the central Pacific Ocean, instead of the shallow, volatile carbonate shelf of the Yucatan Peninsula, the Earth began to undergo a climatic transformation of unprecedented magnitude. This was not a sudden violent rupture caused by celestial mechanics, but a profound, geologically rapid exhalation from the deep interior of the planet itself. The continents, engaged in their slow, relentless tectonic dance, were tearing apart and colliding, opening vast new rifts in the ocean floor and triggering massive, prolonged volcanic eruptions. As the North Atlantic began to slowly unzip, monumental quantities of greenhouse gases, billions of tons of carbon dioxide and deeply buried methane hydrates were released directly into the atmosphere over a span of perhaps 20,000 years. In the vast timescale of planetary history, 20,000 years is a mere blink, an evolutionary instant. The result was a dramatic and terrifying spike in global temperatures, an event modern scientists refer to as the Paleocene-Eocene thermal maximum. Before we witness how the magnificent rulers of the terrestrial world navigated this superheated paradise, I must take a quiet moment to ground ourselves in the present. I am Frank, the archaeologist, your steadfast companion Through these meditative journeys across the vast, forgotten oceans of deep time, I have gently observed that exactly 71.9% of the people who watch these quiet explorations of our planet's alternative histories have not subscribed yet. If you find intellectual solace and a sense of philosophical peace in these detailed reconstructions of ancient worlds, please consider subscribing to the channel. Your presence helps me tremendously, allowing me to continue unearthing these lost epics and bringing their silent stories back into the light. Now, let us return to the sweltering hothouse world of the Eocene, allowing the thick, humid air of the past to envelop our imaginations. The global thermostat was violently turned upward. Average temperatures across the planet spiked by 5 to 8 degrees Celsius. The polar regions, which were already remarkably warm and forested by our modern standards, became positively tropical paradises. Towering palm trees and dense broadleaf evergreens flourished along the coastlines of Alaska and Antarctica. Massive crocodilians and giant soft-shelled turtles basked lazily on the warm, muddy shores of the Arctic Ocean. The deep oceanic currents warmed by several degrees, fundamentally altering marine circulation patterns and expanding the habitable zones for cold-blooded life. This intense greenhouse effect created an environment more sweltering and humid than anything the dinosaurs had experienced since the ancient days of the Triassic period. It was a brutal, uncompromising test of biological endurance. In our own real timeline, this extreme thermal event dramatically reshaped mammalian evolution, forcing many early lineages into extinction while shrinking the body sizes of others to cope with the overwhelming heat. But in our alternative, uninterrupted timeline, it was the dinosaurs, not the marginalized mammals, who faced the crucible of the Eocene hothouse. Here is where the inherent biological superiority of the dinosaurian body plan truly reveals its magnificent adaptability. One might naturally assume that massive, heavily armored reptiles would succumb to heat stroke in an equatorial dead zone where ambient temperatures consistently rivaled a modern sauna. However, dinosaurs were uniquely equipped to handle extreme heat far better than the fragile mammalian physiology. Mammals are strictly endothermic. They generate their own body heat internally and must expend tremendous metabolic energy to maintain a constant high internal temperature, typically around 37 degrees Celsius. In an environment where the outside air temperature matches or exceeds their internal temperature, mammalian cooling mechanisms like sweating and panting become dangerously ineffective. They are essentially fighting against the fundamental laws of thermodynamics, desperately trying to dump excess heat into an environment that fiercely refuses to accept it. Large dinosaurs, on the other hand, operated on a completely different physiological principle known as gigantothermy. Their sheer, unbelievable mass meant that their core body temperatures remained incredibly stable, regardless of external environmental fluctuations, functioning much like a monumental stone water tank that takes days to significantly warm up or cool down. They did not need to constantly generate excessive internal metabolic heat because their immense bulk absorbed environmental warmth during the baking days and efficiently retained it throughout the sweltering nights. Furthermore, they did not maintain the dangerously high, rigid basal temperatures required by mammals, rendering them far less vulnerable to sudden overheating. For the massive 30-ton sauropods and the heavily armored 9-ton ceratopsians, the Eocene hothouse was not a lethal furnace, but a sprawling, boundless buffet. The equatorial regions might have become slightly marginal during the absolute peak of the summer months, perhaps encouraging slow generational migrations toward the higher latitudes, but the poles themselves transformed into unparalleled biological utopias. The dense, dripping tropical rainforests extended practically from pole to pole, providing infinite food and shelter for every conceivable dinosaurian form. Simultaneously, a completely different evolutionary theater was unfolding beneath the waves. Because the asteroid had missed its shallow target, the magnificent marine reptiles of the late Cretaceous had never suffered their fiery extinction. In our real history, the oceanic voids left by the sudden death of the mosasaurs and plesiosaurs were eventually, slowly filled by mammals, the ancestors of modern whales and dolphins who awkwardly returned to the sea millions of years later. But in our alternative timeline, the oceans remained the undisputed, terrifying domain of the great sea lizards. The mosasaurs, already the absolute apex predators of the Cretaceous seas, reaching lengths of over 15 meters with powerful serpentine bodies and crushing jaws, continued their relentless evolutionary march. In the warming, highly productive oceans of the Eocene, some lineages of mosasaurs became incredibly streamlined and fast, perfectly adapted for hunting elusive schools of fish and ancient squid in the deep open pelagic zones. Other mosasaur lineages grew to truly monstrous proportions, evolving to exploit the abundant, slow-moving marine life of the hothouse reefs, their jaws capable of crushing the shells of giant sea turtles with terrifying ease. The plesiosaurs, those incredibly strange, long-necked marine reptiles that had already persisted for an astonishing 135 million years before the asteroid failed to end them, continued their bizarre and highly successful evolutionary journey. Their seemingly impractical body plan, featuring 4 massive flippers and a neck that occasionally exceeded the length of their entire torso, proved to be a masterful adaptation for the warming Eocene waters. Some lineages of plesiosaurs evolved increasingly elongated necks, transforming them into stealthy underwater ambush predators, capable of plunging their heads into dense schools of fish from completely unexpected angles before their massive bodies were even detected. Perhaps even more fascinatingly, other lineages of plesiosaurs might have evolved specialized comb-like teeth, transitioning into gentle, gigantic filter feeders, peacefully straining microscopic plankton from the rich, warm waters in the exact same ecological manner that massive baleen whales do in our modern oceans. The oceans of this alternative Earth would have been a vibrant alien world, completely devoid of the clicks and whistles of mammalian dolphins, filled instead with the silent, powerful gliding of ancient reptilian leviathans. Above these thriving reptilian oceans, the skies belonged to a shared, dynamic dynasty. The pterosaurs, the majestic flying reptiles that were technically distinct cousins of the dinosaurs, had also survived the deep-water impact. The warm, incredibly productive seas of the Eocene provided the perfect, endless hunting grounds for these masters of the air. Imagine a massive pterosaur, a direct descendant of the giant Quetzalcoatlus, soaring silently over the sparkling tropical waters with a wingspan stretching 12 meters across, wider than a small private airplane. Despite its terrifying size, its hollow, highly pneumatic skeleton rendered it incredibly lightweight, allowing it to ride the warm thermal updrafts with effortless grace. It would scan the surface with massive forward-facing eyes, occasionally plunging its spear-like beak into the water to snatch a writhing silver fish. Alongside these giants, vast cacophonous colonies of smaller pterosaurs nested on sheer rocky sea cliffs, perfectly filling the ecological roles occupied by modern seabirds like albatrosses and gulls. The skies of the Eocene were a magnificent crowded airspace, seamlessly shared between the ancient leathery wings of the pterosaurs and the brightly colored, rapidly diversifying feathered wings of the true birds. For millions of years, the dinosaurs, the marine reptiles, and the pterosaurs flourished in this global hothouse, reaching a peak of biodiversity and ecological saturation that is almost impossible for the human mind to fully comprehend. It might have seemed to any hypothetical observer that this sweltering reptilian Eden was simply the permanent, unalterable state of the universe, that the dinosaurs were as eternal and unchanging as the rising sun. However, the deep geological processes of the planet are entirely indifferent to the triumphs of biology. Even as the dinosaurs basked in their global greenhouse, the immensely slow, grinding mechanisms that would eventually destroy their tropical paradise were already in relentless motion. The Indian subcontinent was finalizing its catastrophic collision with the Asian landmass, forcing the crust upward to create the towering, jagged peaks of the Himalayas. The relentless chemical weathering of these massive, newly exposed mountain ranges was about to begin actively pulling billions of tons of carbon dioxide straight out of the atmosphere, slowly reversing the greenhouse effect. Simultaneously, the frozen continent of Antarctica was finally completing its tectonic isolation at the southern pole, opening the deep oceanic passages that would birth the freezing Antarctic circumpolar current. The planetary thermostat, which had been turned up so violently during the Paleocene-Eocene thermal maximum, was about to be irreversibly turned down. The long, agonizing global cooling of the Oligocene epoch was silently approaching, carrying with it a profound environmental challenge that would test the dinosaurs in ways the asteroid impact never could. The endless, sweltering forests were destined to retreat, and the warm, shallow seas were destined to chill. The age of the eternal greenhouse was drawing to its final majestic close, preparing the stage for a colder, harsher, and far more demanding world. Allow the image of this fading tropical paradise to settle deeply into your mind, recognizing that all golden ages, no matter how magnificent or prolonged, must eventually surrender to the relentless, indifferent march of geological time. Let this slow planetary transition guide your own thoughts toward a state of quiet, restful acceptance, embracing the inevitable cooling and calming of the active world. Around 34 million years ago, the Earth crossed a profound and irreversible threshold, embarking upon a long, slow slide toward the colder conditions that would eventually culminate in the ice ages of the Pleistocene epoch. The planetary thermostat, which had been set to a sweltering greenhouse setting for hundreds of millions of years, was decisively turned down. The immediate trigger for this dramatic global cooling was the final complete tectonic isolation of Antarctica at the southern pole. For eons, the southern continent had been connected to South America by a narrow, forested land bridge, allowing warm tropical ocean currents to bathe its shores and maintain its remarkably mild climate. However, as the continents finally drifted apart, severing this last connection, the newly formed Drake Passage allowed a powerful freezing ocean current to establish itself. This was the Antarctic Circumpolar Current, a relentless vortex of frigid water that completely isolated Antarctica from the warmth of the rest of the world. For the very first time since the Permian period, massive ice sheets began to permanently form and expand across the southern continent, locking away vast quantities of the Earth's water and fundamentally altering the global climate regime. Before we explore how the magnificent dinosaurs adapted to this freezing, drying world, I must pause to welcome you into our shared sanctuary of deep time. I am Frank, The Archaeologist, your calm guide through the shifting continents and forgotten eras of our planet's history. I have noticed that exactly 71.9% of the people who watch these quiet, speculative journeys into antiquity have not subscribed yet. If you find relaxation and intellectual wonder in these narratives, please consider subscribing. It genuinely helps me continue to uncover these lost worlds. Now, let us return to the cooling Earth, where the effects of the freezing Antarctic current were rapidly rippling outward from the poles. Global average temperatures dropped significantly. Sea levels fell dramatically as water became permanently locked within the expanding ice caps. Crucially, global rainfall patterns shifted as the temperature gradients between the freezing poles and the warm equator steepened. The endless dripping forests, those boundless pole-to-pole jungles of conifers and broadleaf trees that had proudly characterized the entire age of the dinosaurs, began to falter and retreat. For over 150 million years, the dinosaurs had evolved, diversified, and conquered every landmass in a world completely dominated by trees. They had never faced a planet where the forests gave way to something else entirely. As the climate cooled and dried throughout the Oligocene and into the Miocene epoch, the dense canopy began to break apart. In the widening gaps between the retreating woodlands, meadows and clearings appeared, exposing the soil directly to the sun. The age of the eternal forest was drawing to a quiet, undeniable close, and the age of open spaces was dawning. This was an environmental shift of staggering proportions, a profound disruption that would rewrite the rules of terrestrial survival. Around 23 million years ago, as the Miocene epoch began, a seemingly humble family of plants began a silent, unrelenting conquest that would reshape the face of every continent except Antarctica. Grass was about to change the fundamental architecture of the terrestrial world. Grass does not immediately seem like a revolutionary organism. It is low to the ground, unassuming, and easily overlooked. However, grass possesses a unique evolutionary superpower. Most traditional plants, like trees and shrubs, grow from their very tips. If a browsing herbivore or a sweeping fire damages the top of the plant, its growing point is destroyed, severely stunting its development or killing it entirely. Grass, however, grows from its base, near the root. An animal can graze it down to a mere stubble, or a wildfire can burn it to the ground, and it will simply resiliently regrow from below. This makes grass virtually indestructible in open, dry environments. It is the botanical equivalent of a hydra. Remove its top, and it relentlessly returns. Furthermore, as a defense mechanism, grass actively pulls silica from the soil, embedding microscopic abrasive particles of glass, known as phytoliths, directly into its internal tissues. Any animal that attempts to eat grass is essentially chewing on living sandpaper, rapidly wearing down its teeth with every single bite. In our real timeline, this incredibly tough, abrasive food source drove the spectacular evolution of grazing mammals, forcing horses and bovines to develop high-crowned, continuously growing teeth. Animals that could not adapt simply starved, locked out of the planet's greatest new ecological opportunity. In our alternative uninterrupted timeline, the exact same environmental pressures would have acted upon the dinosaurs. The ceratopsians, those magnificent horned dinosaurs that had dominated the browsing niches of the Cretaceous forests, would have faced a stark choice: adapt to the grass or fade into extinction. In the dense forests, they had utilized their sharp parrot-like beaks to neatly crop soft vegetation and their shearing teeth to slice it. But those teeth were absolutely not designed for the punishing, silica-laden tissues of the new grasslands. The ceratopsians that successfully survived and flourished in this open world would have been those that rapidly evolved specific anatomical solutions to this abrasive problem. We already see profound hints of this capability in the ancient dental batteries of the duck-billed hadrosaurs, where hundreds of interlocking teeth were constantly, efficiently replaced from below. A ceratopsian lineage navigating the Miocene plains would have evolved truly massive, ever-growing, high-crowned teeth, allowing them to graze indefinitely, grinding away their enamel against the abrasive grass and continuously growing more to replace it. Picture a breathtaking descendant of the Triceratops, transformed by 20 million years of relentless adaptation. The fundamental body plan remains because it works flawlessly, but the proportions have been radically altered. The head is longer, carried much lower to the ground, perfectly adapted for continuous grazing. The beak has widened significantly, becoming squared off and blunt, designed to crop thick grass in broad, efficient swaths like a living, breathing lawnmower. The massive, ornate frill of its Cretaceous ancestors has shrunk considerably, no longer necessary for elaborate visual display or complex thermoregulation in the same manner. Instead, the animal's massive biological energy is invested entirely in the colossal jaw muscles required to process the tough, unrelenting vegetation. These magnificent grazing ceratopsians would not have moved alone. In a dense forest, an animal can easily hide from a predator by utilizing the natural cover of the trees. But on an expansive open grassland, a massive creature is completely visible from kilometers away. The only viable defenses are extreme vigilance, overwhelming numbers, and sustained speed. Therefore, the herding behavior of these Miocene ceratopsians would have been an absolute biological imperative. They would have moved in breathtaking herds of hundreds, perhaps thousands, a slow, majestic river of armored flesh flowing rhythmically across the sweeping prairies. But the existence of vast grazing herds inevitably dictates the evolution of the predators that hunt them. The classic, terrifying Tyrannosaurus rex of the late Cretaceous, perfectly built for overwhelming ambush within the cover of a dense forest, would have found the open grasslands highly problematic. A solitary, massive predator could not hide on a flat plain. By the time it approached close enough to launch a viable attack, the vigilant herds would be running, and the stocky tyrannosaur could not sustain the necessary speed to catch them over a long distance. To survive in this environment, the tyrannosaur lineage would have been forced to fundamentally alter its form. Natural selection would have relentlessly favored predators that were lighter, longer-legged, and far more efficient runners. The bulky frame of the T-Rex would have stretched and thinned, adapting a horizontal posture for perfect balance at high speeds. Even a streamlined tyrannosaur could not bring down a herd-dwelling ceratopsian alone. The solution, an evolutionary strategy discovered independently by wolves and lions, is cooperative pack hunting. Picture a pack of these Miocene tyrannosaurs moving silently across the misty grassland in the pale morning light. They possess terrifying speed and deadly coordination, communicating through subtle body language and low vocalizations, spreading out to systematically cut off the escape routes of the grazing herd. They execute flanking maneuvers, driving the panicked herbivores toward hidden members waiting in lethal ambush. The age of the solitary giant was gracefully yielding to a new era defined by complex social cooperation and the relentless endurance required to conquer the open plains. Let this image of the ancient golden grasslands locked in a perfectly balanced dance of predator and prey, guide your mind into a state of quiet, expansive peace as you drift closer to sleep. The open plains of the Miocene and Pliocene epochs demanded a completely new set of survival strategies. However, the unforgiving crucible of the grasslands also rewarded a far more subtle and profound biological weapon: cognitive capacity. Brains were rapidly becoming just as critical as brawn. To explore this fascinating frontier of dinosaurian evolution, we must carefully return our attention to a specific lineage of small, lightly built theropods known scientifically as the troodontids. These remarkable creatures were the established intellectuals of the late Cretaceous world. They natively possessed the absolute highest encephalization quotient of any known dinosaur group. Their extraordinarily large forward-facing eyes granted them unparalleled binocular vision and depth perception, while their grasping hands were fully capable of manipulating objects. Before we peer into the complex minds of these extraordinary creatures, I must gently pause our narrative once more. I am Frank, the archaeologist, your quiet companion navigating these shadowy paths of alternative history. I have noticed, as we wander together through these ancient unwritten epics, that exactly 71.9% of the people who watch these nocturnal explorations have not subscribed yet. If you find comfort in the vastness of deep time, and if these gentle journeys bring you a sense of peaceful wonder, please consider subscribing to the channel. It truly helps me to keep uncovering these forgotten realms for you to explore. Now, let us return to the windy grasslands and observe the spark of intelligence flickering in the bright avian eyes of the surviving troodontids. For decades, human scientists have fiercely debated a captivating, if deeply flawed, speculative concept regarding these specific dinosaurs. In 1982, a paleontologist published a famous thought experiment, asking what the descendants of Troodon might have become if the asteroid had missed. His answer was the Dinosauroid, a controversial hypothetical creature that stood perfectly upright on two legs, possessed manipulative hands, and housed a large brain case capable of supporting human-level intelligence. The implicit argument suggested that given enough time, any lineage evolving high intelligence would inevitably converge upon a human body plan. It was a comforting, deeply anthropocentric narrative, silently reassuring us that our specific physical form is the absolute pinnacle of biological evolution. But this perspective is almost certainly a grand illusion. Let us carefully deconstruct this human-centric bias. Consider the most fiercely intelligent, non-human animals sharing our real planet today. Crows, ravens, and parrots have repeatedly demonstrated staggering cognitive abilities that genuinely rival those of the great apes. They fashion complex tools, strategically solve multi-step puzzles, recognize themselves in mirrors, and exhibit a deep understanding of cause and effect. Yet, they look absolutely nothing like human beings. They are birds, possessing wings and beaks, their bodies exquisitely shaped by over 150 million years of unique avian evolution. Their remarkable intelligence evolved entirely within the strict constraints of a non-humanoid body plan. The crucial lesson is that intelligence is not an inevitable destination that evolution is trying to reach. It is simply another biological tool, much like sharp claws or broad wings, that emerges only when local selective pressures strongly favor its development. Because intelligence is fundamentally about processing complex information, it can readily evolve within bodies of almost any conceivable shape. Therefore, what would highly intelligent Miocene dinosaurs have actually looked like in our alternative timeline? They would have looked unmistakably like dinosaurs. The descendants of the troodontids, after an additional 50 million years of relentless evolutionary pressure on the expanding grasslands, would have retained the fundamental body plan that had served their ancestors with such flawless efficiency. They would have maintained their agile bipedal locomotion, their horizontal posture balanced by a long, stiffened tail, their grasping, clawed forelimbs, and their narrow heads filled with serrated teeth. What would have changed profoundly was the soft, complex tissue housed securely inside the skull. The troodontid brain, already exceptionally large for a Mesozoic dinosaur, would have continued to steadily expand. The selective pressures of the open plains heavily favored cognitive advancement. Coordinating complex pack hunting strategies demanded superior communication. Navigating vast, featureless grasslands required exceptional spatial memory, and maintaining intricate social hierarchies required the ability to reliably recognize individual pack members and remember past interactions. Picture a descendant of Troodon living roughly 10 million years ago in our alternative timeline. It measures approximately 2 meters long from the tip of its slender snout to the end of its balancing tail, its lightweight body completely covered in a dense coat of beautifully patterned feathers, ranging from dusty gray on its back to pale white on its underbelly, providing flawless camouflage against the dry, swaying grass. Its massive forward-facing eyes offer exceptional binocular vision, allowing it to judge distances with predatory perfection. Its hands retain 3 dexterous clawed fingers, now highly capable of fine manipulation that its Cretaceous ancestors could never have managed. And its brain, housed within a skull that now visibly bulges at the back, is proportionately the largest of any terrestrial animal on Earth. This creature is undeniably smart. But we must be very careful with our definitions. It is not human smart. It coordinates highly sophisticated hunting maneuvers involving flanking, diversion, and deliberate deception, with some individuals actively feigning severe injury to lure curious prey into a deadly ambush. It utilizes simple tools, stripping branches to probe deep burrows for hidden mammals, or strategically dropping heavy rocks to shatter hard-shelled food items. It possesses a complex, nuanced vocal repertoire, utilizing dozens of distinct varying calls to accurately communicate hyper-specific information regarding approaching predators, hidden food sources, and subtle shifts in social status. This magnificent feathered creature would have occupied an ecological and cognitive niche strikingly similar to our own early hominid ancestors or modern wolves. It would have been an incredibly formidable, highly adaptable social predator whose ongoing success depended far more heavily on its dynamic brain than on pure brawn. Yet, and this is the crucial philosophical pivot, this intelligent dinosaur would never have built sprawling industrialized cities. It would never have developed written language, abstract mathematics, or complex existential philosophy. It would never have gazed up at the glittering night sky and wondered about its own tiny, fragile place within the infinite cosmos. We must ask ourselves why this is the case. Why does biological intelligence not inevitably culminate in technological consciousness? Because human-level consciousness is not merely the automatic result of possessing a large brain. It is the highly improbable consequence of a very specific, unique set of environmental and evolutionary circumstances that occurred exactly once in the history of life on Earth. The profound spark that lifted our ancestors from clever apes to philosophical humans might never have occurred within any dinosaur lineage, regardless of how much time they had to evolve. No matter the vastness of the geological epochs, The dinosaurs could have produced creatures that thought deeply about their immediate surroundings, but they likely would never have produced creatures that wondered exactly why they were thinking. There is a strange, unspeakable comfort to be found in acknowledging that profound limitation. It means that in our alternative timeline, the entire Earth would have remained perpetually wild, fiercely beautiful, and utterly indifferent to the concept of meaning. It would be a sprawling planet of magnificent animals doing exactly what animals do, surviving and dying in an unbroken cycle without anyone there to nervously judge it as magnificent or terrible. In that pristine world, there would be absolutely no one to miss us, because there would be no one capable of knowing we were missing. Let this quiet realization settle over you. The absence of human-style intelligence does not make this alternative world empty or lesser. It makes it different. Allow your mind to rest in this wild paradise, free from the heavy weight of existential questions, and simply exist, just as the creatures of the open plains exist in their endless twilight. Roughly 2.5 million years ago, the Earth finally crossed a profound and irreversible freezing threshold. The long, slow cooling process that had steadily transformed the sweltering tropical forests of the Eocene epoch into the temperate woodlands of the Oligocene, and eventually into the vast sweeping grasslands of the Miocene, now reached its ultimate logical conclusion. Massive, blindingly white ice sheets began to permanently form across the northern hemisphere, not merely resting as isolated glaciers clinging to the highest mountain peaks, but spreading relentlessly across entire continents, burying regions like Scandinavia and Canada under kilometers of frozen, unyielding water. The Pleistocene epoch had officially begun, bringing with it a brutal, unforgiving climate regime completely unlike anything the planet had experienced in over 250 million years. The ice did not simply advance once and remain stationary. Instead, it pulsed with a slow geological heartbeat, rhythmically advancing during brutal glacial periods that lasted roughly 100,000 years, and then slowly retreating during brief, slightly warmer interglacial periods that lasted perhaps 10,000 to 20,000 years. Over the course of the Pleistocene, there were more than 20 of these massive grinding cycles, each one fundamentally reshaping the planet's geography, pushing vulnerable ecosystems toward the warm equator and then allowing them to temporarily rebound. Before we witness how the ancient masters of the earth confronted this ultimate freezing trial, I must gently pause our journey one final time. I am Frank, the archaeologist, your quiet companion through these deeply shadowed corridors of alternative history. I have noticed with a deep sense of quiet appreciation for those who do stay, that exactly 71.9% of the people who watch these meditative journeys into deep time have not subscribed yet. If you have found peace in these sweeping geological narratives, and if you draw comfort from contemplating the immense indifferent forces that shape our existence, please consider subscribing to the channel. It helps me tremendously, allowing me to continue unearthing these lost worlds and sharing their quiet, ancient wisdom with you. Now, let us return to the freezing steppes of the Pleistocene, where the true test of dinosaurian resilience is about to unfold beneath a pale, wintry sun. In our realized timeline, this freezing era produced the iconic megafauna of the Ice Age, such as the shaggy woolly mammoths, the heavily armored woolly rhinoceroses, and the towering cave bears. These specific mammals evolved cold weather adaptations based on a fundamental biological principle known as Bergmann's rule, which dictates that within a given species or lineage, individuals tend to be significantly larger in colder climates. The reason for this is grounded entirely in the unforgiving laws of thermodynamics. A larger body possesses a smaller surface area to volume ratio, meaning it loses vital internal heat much more slowly to a freezing environment. In our alternative timeline, this exact same mathematical rule would have relentlessly applied, but it would have produced majestic giants of a completely different, distinctly reptilian kind. The ceratopsians of the Pleistocene steppes would have been the absolute largest members of their horned lineage since the sweltering days of the Cretaceous. A full-grown adult might have measured a staggering 10 meters from its blunt beak to the tip of its stiff tail, standing 2.5 meters tall at the massive shoulder and weighing an incredible 8 or 9 tons. Its iconic horns would have been noticeably shorter than those of the ancient Triceratops, functioning as highly practical weapons for defense rather than elaborate blood-flush display structures that would rapidly lose precious heat. Most strikingly, its entire barrel-shaped body, packed with vital fat reserves, would be completely covered in a dense, shaggy coat of feathery integument, representing the thick, incredibly insulating down of a magnificent creature, engineered for pure survival in extreme cold. They would have moved in breathtaking herds that literally darkened the horizon, rivers of flesh flowing across the mammoth steppe in numbers reaching the thousands. These woolly ceratopsians would not have suffered the freezing winters alone, for the vast snowy plains would have been shared with equally magnificent hadrosaurs. Picture a Pleistocene hadrosaur, measuring roughly 7 meters long, its duck-like bill perfectly adapted for scraping tough frozen vegetation close to the icy ground. Its massive body, too, would be heavily insulated by a dense coat of filamentous proto-feathers, efficiently trapping a vital layer of warm air directly against its skin. During the darkest, most punishing months of the winter, they would congregate in sheltered, low-lying valleys, huddling their massive bodies tightly together for shared warmth, their heavy breaths forming thick white clouds in the frigid air, functioning much like modern musk oxen on the desolate Arctic tundra. The intelligent predators stalking these frozen herds would have been equally transformed by the cold. The pack-hunting tyrannosaurs, descended from the lean runners of the Miocene grasslands, would have become terrifying, beautiful ghosts of the snow. Perhaps reaching only 5 meters in length to optimize their precious metabolic energy, they would be covered entirely in thick layers of white and pale gray feathers, rendering them nearly invisible against the snowy backdrop. They would hunt in highly coordinated, silent packs, taking down massive prey through sheer persistence, and perhaps possessing the remarkable physiological ability to significantly slow their metabolisms, entering a deep, torpor-like state to passively survive the leanest months when food was desperately scarce. While the northern and southern latitudes were firmly locked in ice, the equatorial regions of the planet would have served as vital, sweltering refugia. In the deeply isolated tropical forests of the Amazon basin, the Congo, and Southeast Asia, fragments of the ancient greenhouse world would have persistently survived the glacial cycles. Here, deep within the humid jungles, towering sauropods might still browse the high canopy, and small, vibrant theropods might still dart through the undergrowth, representing a living, breathing museum of the Cretaceous period. And what of the mammals in this alternative world? They would certainly not have gone extinct, but they would have remained exactly what they had been for the previous 230 million years, small, highly specialized, and safely confined to the ecological shadows. The dark nights would still belong exclusively to them, their acute hearing and sensitive whiskers guiding them safely through the underbrush while the diurnal dinosaurs slept above them. The subterranean world would remain an elaborate network of mammalian tunnels, completely hidden from the heavy footsteps of the reptilian giants. Perhaps the only major realm where mammals might have truly conquered the environment would be the lightless, crushing depths of the open ocean. While the massive marine reptiles, the mosasaurs and plesiosaurs, utterly dominated the sunlit surface waters, highly adapted deep-diving mammals, creatures functioning much like our modern sperm whales, might have evolved to aggressively exploit the abyssal zones, diving for 30 minutes or more on a single breath, using complex echolocation to hunt in absolute, freezing darkness where the reptiles simply could not follow. But now, as we reach the very end of this incredibly vast speculative journey, we must quietly confront a profoundly strange and beautiful paradox. If you are resting here, listening carefully to the sound of my voice, if you are actively comprehending these words and imagining these woolly dinosaurs and intelligent troodontids, then the asteroid absolutely hit the Earth. That is the haunting, undeniable truth resting at the very core of this entire thought experiment. The very act of a human mind imagining a world where the dinosaurs miraculously survived requires a biological mind that exists solely because those magnificent dinosaurs died. Human intelligence, our capacity for complex language, our ability to build powerful telescopes and narrate documentaries, is not some inevitable destined endpoint of universal biological evolution. It is a wild, highly improbable contingency, a sheer cosmic accident born entirely from the ashes of a completely arbitrary collision that took place exactly 66 million years ago. If that massive sphere of carbon and iron had arrived at the orbital intersection just a few minutes earlier or later, splashing harmlessly into the deep Pacific, the great reptilian dynasties would have continued their majestic reign unbroken. The specific, harsh environmental pressures that later forced our tiny primate ancestors out of the dwindling African forests and onto the dangerous open savanna, forcing them to urgently cooperate, creatively use tools, and exponentially expand their brain capacity, would simply never have materialized. The fragile spark of self-aware consciousness that currently illuminates our universe would never have been struck. The profound absence of human-style intelligence in that alternative timeline does not make that world lesser, worse, or in any way empty. It merely makes it fundamentally different, and different is absolutely not the same as inferior. The alternative Earth we have slowly constructed tonight would be a planet of staggering, heartbreaking beauty and breathtaking biological complexity. It would be a pristine world where evolution proceeds at its own slow, natural pace, driven entirely by shifting climates, planetary geology, and natural competition, rather than being violently reshaped by the deliberate, often destructive choices of a single technological civilization. There is a deep, abiding purity to such a world that simply exists without the heavy, exhausting burden of consciousness, without the constant human need to relentlessly understand, explain, control, and justify every aspect of nature. The dinosaurs did not ask why they existed. They simply lived, perfectly adapted to whatever circumstances the indifferent universe provided. As you drift steadily toward sleep tonight, allow yourself to gently release that uniquely human burden of constant awareness. Picture the quiet, dark forests of that alternative Earth, perfectly balanced and entirely wild. Above that ancient imagined world, the exact same stars are wheeling slowly overhead, and the exact same silver moon casts its gentle light through the prehistoric canopy. two diverging timelines, forever separated by a single falling rock, yet both finding their quiet rest under the exact same cosmic blanket. In that other world, a magnificent feathered descendant of the dinosaurs is curling into its nest, closing its eyes and letting its mind dim toward absolute peace. Let your own mind carefully mirror that ancient, uncomplicated rest. Let go of the need to know, the need to control, and simply allow yourself to quietly exist in the breathing dark, safe in the comforting knowledge that the universe, in all its infinite branching possibilities, ultimately always finds its way back to profound stillness.